I just completed connecting my address and data lines to my bus. So real quick as a reminder, I have a pair of data transceivers here. And so I'm coming out of the data lines for the processor into those transceivers, out of the transceivers into the data lines on this bus distribution board. As far as the address, I'm going through 3 latches for that. So I've got my address pins coming into the 3 latches, out of the 3 latches into, again, this bus distribution board. So the bus is carrying at this point 24 address lines and 16 data lines. And then you can see I also connected in an Arduino up here in the upper right. And basically same thing. I'm just taking all 24 address lines and the 16 data lines into these 2 headers on the Arduino. I still have more stuff to connect to the Arduino, like clock and enable signals, things like that, all the bus cycle status signals, but I'll come back to that. I kind of wanted to get this wiring done because it's a little bit bulky, and I want to get it laid down before I start trying to work things around it. One thing I have had issues with in the past is when I have a whole series of connections like this into a breadboard, it's really hard to lose track of when one is slipping out or you don't get a good contact. So that's where I made up these little PCBs, and maybe at the simplest, I've been experimenting with them too here, so you'll see a few different ways that I'm trying to use them just to kind of test it out, I guess. But when it comes to these data lines up here, I'm using one of these that is a 2x, well, in my case, it's a 2x20 PCB, but then I cut it down. I have a simple little table saw that works really well for trimming PCBs. So I trimmed that down to be 16x2, and I put in a pin header, and that pin header goes into then the breadboard, which is connecting to the pins on this PCB to the processor. And then on the other row, essentially, I'm then soldering in the actual wires. And then those come over here to these transceivers, where then I'm using a 2x8 version, just again cut down with pins and then the wires soldered in. So really no single pin is going to come out here. If something's going to come out, it's going to be the entire set, and that is pretty unlikely, or at least it's visually really clear if an entire set is creeping out of the breadboard for some reason. Then down here, I experimented with a 3x version. So I grabbed a couple of these. I needed obviously 24 pins worth for the data. I put in a double row pin header and then a single row for soldering. And I actually like that. That's my preference at this point because it really holds on well to the breadboard. Whereas with the data, it can actually tilt a little bit. With the double row, it doesn't tilt. It's a nice solid connection. And then, of course, I run these down. Again, I'm just using the simpler 2x8 little headers here and have those soldered in. Then when I got to connecting these into this board, a couple of things. I did use some double-sided adhesive tape, basically down at the bottom and top, just to keep this board somewhat in place. I don't intend to pick it up or do any more soldering in it. It's going to stay the way it is at this point. But what I did for these connections is I again used the basically 2x, and I grabbed a pair of, let's see if I have one sitting here, actually up here. I just grabbed a pair of these that allow me to basically click into the male pin headers that I've soldered in. And then on one side, I put a 2x, and then I put another one of these in, and on the other side, I put another 2x. And so essentially what that's ended up with, and it's kind of hard to do this while I'm holding them, is just a pair of connections that I can just drop in. I then did end up cutting it into 2 sections. So I got the data on its own PCB, upper and lower, just as far as rows here. And then all the rest of the address lines each have their own singular PCB for the upper or lower row here. And that seems like a very solid connection. So assuming I didn't mis-solder anything there or somehow transpose some wires, which I was really careful not to do, but this had a lot of wiring, so possible that that might not check out, but I think I have everything soldered properly to the right pins. It was interesting. I did some initial just ohming out of the signals, and one of the pins wasn't connecting, and it took me a little bit to kind of just track back. But as I flipped the board over, I had missed soldering a pin on the actual pin header on the PCB. So silly mistake, but I was able to track that down as I couldn't. I was getting signal in, but then I couldn't go to another comparable pin on a different header and get the same signal out of it. So that didn't leave much other than a problem with the connector or the board. So flipping it over, saw that. This up here, similar type of thing. I used the same type of header. You can see the wires here. I came down and soldered. This one on the right, I started that way. And then on the left, I thought I'd experiment with bringing the wires from the bottom up. And that's actually a bit easier for soldering because then all the soldered side of it is together there. Versus here I've got the central pin headers pointing with the solder up top, with the wires, all the solders on the bottom. But here then I have all of the connections. So I got the 24 plus 16, so there's 40 wires here. I did not want to try to do more 22 gauge. This is a 22 gauge with a pretty thick insulator on it. Not the thickest, but thick enough that if I was to take all of this, it would be a pretty big clump. So I decided to use some different solid core wire, and I just pulled this out of some Cat 5 cable that I had lying around. I've got a couple spools of extra Cat 5 cables, so grabbed some Cat 5 cable, stripped out the wires. I know that's not probably ideal. Some of these are twisted together, some of these were pulled apart, and I know that probably has some impact to the signal, and at higher speed, that's probably a concern, but keep in mind the debugger, I'm only ever going to be debugging low speed. Once it gets going fast enough where that wire is going to matter, you're well beyond what the Arduino is going to be able to keep up with as far as reading those signals. So I've got address and data on here, and then my lower 16-bit address here. I've got my data here, and my upper 8 of the address is sitting there. And so right now this seems like that's working pretty well. I do also have a 4x header, and that allows me to just quickly bridge upper and lower parts of a breadboard. So I can just put in a bottom row pin header, top row pin header, and then click it in place, and now these are joined. Plus it gives me those 2 middle pins to actually connect wires into, solder wires into. And again, I can cut that to whatever width I need. And then this version just goes between breadboards. So while this one helps me connect sections within a breadboard, this one, same concept, but it allows me to jump between 2 different breadboards. So if I wanted to connect these here to these up here, I could just solder in 2 pin headers and put this down. When it comes to the smaller, the 2x's, these are easily snipped. The 3 got a little bit harder to snip just with the side cutters. And then I don't think I would try the 4. That seems to be too much to try to catch with just a side cutter. And obviously this you're never going to do with a side cutter. So that's where I'm using a little table saw. It's basically just an upside down jigsaw. And I put in a fine metal blade in that, and it cuts PCBs really well. So I am getting close to actually firing this up and seeing if I get any magic smoke and how many issues I have with just getting the processor reset going. Again, I've not hooked up my interrupt controller or the math coprocessor or ROM or RAM or any I/O. That's all stuff that's going to come later. But I think the next step I'm going to do, I do have this, instead of a piece of paper here, I do have the actual PCBs on hand. And this is how they turned out. So you can kind of see it's pretty close to my really fancy printout there. But I'm going to work on getting this assembled and see what issues I might have with it. If this ends up working, at least as far as the clock and reset, that's my biggest concern, is to get that clock going. I will get this mounted in here. and then I'll get my clock and reset signals actually connected, and I will get these power lines connected. So I've got power, 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 3 of them that'll have to get connected into here. And then I think I should be able to fire this up and see, am I getting anything on these bar graphs? Looking for the normal reset process that it would go through. And if I see that the reset looks like it's doing what I would expect, then the next step will be to come in and hook up my ROM and RAM, and I'll probably do that all in one fell swoop. I have maybe choices of how I want to connect these in. I did leave a spot, and actually I noticed I was going to put the Arduino up here, but I ended up putting it down here, so that's fine, no big deal. And actually that maybe leaves less clutter for this right now. These PPIs don't need a lot for addressing, well, they don't need many addressing lines at all, if I remember right. So I can, over here in my schematic, go take a look. But when it comes to addresses, you can see I'm going to have to bring in some data lines, and then I'm going to have to bring in address line 1 and 2, but that's about it. So I'll have a minimal set of wires coming from here, and I'll probably just bring that over to both of these simultaneously. And there, what I might do is I might do this same connector here, but then on top of that, put the 3x. And so then I can run one of these rows to one and the other row to the other. And being that I'm only going to be pulling the 8 data lines plus a couple of address lines, that I think will be manageable. So sitting here then will be some form of a connector that pretty much like you see here. And then I'll have the right sized PCB sitting on top of it. I'll put another one down right below it. Let's see if I can do this without poking myself. And then I'll grab another one of these 3x. And this would be broke up and on the appropriate pins. Solder those on, and then grab my 8 data lines and duplicate the output, one to each of these, and then my address lines, and those will go to each of those. So I think that will work out just fine there. So I'll update these stickers. So this will be both PPIs. I've got the logger. I've got my stuff coming in. RAM and ROM, I then have to decide, do I want them each to go to their own header, or is that more work than is necessary? And maybe what I'll do then instead, or what I could consider doing, we'll see, I've got to think about this, but do I just simply run it to the first set and then kind of duplicate it to the others all off of one header? Or would I do that same type of thing where I would go with the 3x like I did up here? That probably gets to be too much wiring here. I would say it's tedious to do all of these connections like this. So I really don't want to do too many all at once in one cluster. It's better if I can break them up and have fewer that I'm trying to all solder together at once. So maybe as I'm talking through that, what I'll do is I'll maybe make one set go from here up to these, and then from here up to these. So I'll either do that, or I'll run a single set and then just run breadboard wires at that point. And all of those connections here will use, again, I'll use the little 2x header, and I'll cut these down to the 8 or whatever size I need. With these, maybe all the address and data lines aren't contiguous, but I can put down a full header and just put in the wires I want, solder them, bring it over here, so I can bring it over, drop it in, and then maybe if I, at that point, used a 3x, so I could grab a 3x, however, I need to cut it. This one I just snapped in half, but the wire coming in can go in here, plus the pin header, plus the wire to the next one, and then over here I could have a 2x. Or I could have a 3x and I bring it up here and then just kind of keep that cascade going. So that might be just as easy to do, and makes this more digestible and less clutter here. Plus then that'll free up another slot that on this bus board if I want to use it later. Recall that I've left room so that later as I expand this system, I can come in and put another board here I can put another one down here. So these might need to leverage a connection down here. And I might also end up with one up here. So I tried to route everything and leave room so that I can bring in 4 more breadboards. And if I had one open down here to feed one or the other breadboard here, that might be handy. And I've got this one left open, which I'm going to use here. And that maybe leaves this one open also. So the other option is maybe I connect these PPIs with this one and try to leave this one more open so that it's closer to these if I get to that point. So maybe that's what I can do. I can just kind of go from here to here, and then I'll jumper up to this one. So PPIs there. Okay, that's enough trying to think out loud here. But I think I will either have something ticking away here sometime soon, or I will have something that goes up in smoke, and I'll get to step back and figure out what's going on.